Hello guys. So today we are going to be doing sequences. We're going to be going into sequences and series, which starts with chapter 11. We're going to be in 11.1 today. So definition, we're going to talk about two different types of sequences. We're going to talk about infinite where it keeps going and going and going, and finite where it stops. Okay, you see the end result. So the first one, it says write the first four terms in the sequence whose nth term or general term is given. So here they told us a sub n is 2 times n plus 5. So if we want to find the first term, we're going to plug in 1. 2 times 1 plus 5. We get 2 plus 5, which is 7. If we want to find the second term, 2 times 2 plus 5. And we get 4 plus 5 is 9. We want to find the third term. Oops. Oh, that was good. 2 times 3 is 6 plus 5 is 11. And the fourth term, we're going to plug in 4. So you're just plugging in whatever term you're on. 8 plus 5 gets me 13. So there's my first four terms, 7, 9, 11. 7, 9, 11, and 13. Next one looks a little more complicated, but same process. So if we want to find the first term, we're going to plug in 1. Negative 1 to the first power over 2 to the first power plus 1. So we got negative 1. 2 to the first is 2 plus 1 is 3, negative 1/3. Let's plug in 2. So we've got negative 1 to the second power. 2 to the second power plus 1. So negative 1 squared gets me positive 1 this time. 4 plus 1 gets me 5. Third term, negative 1 cubed. And 2 cubed plus 1. So we got a negative 1 again. 2 cubed is 8 plus 1 is 9. Negative 1/9. And I'm running out of room, so we're just going to put the fourth term over here. Negative 1 to the fourth, and 2 to the fourth plus 1. So we're just plugging in that 4. We get positive 1, 2 to the fourth plus 1 more gets me 17. So 1/17. And those would be my first four terms. Now the next one, it says find the first four terms of the sequence. And they give you the first, right? This is my first term, so we don't have to find that one. A sub 1 equals 3. And then they give you something called a recursive formula. Recursive. And what it means by recursive is, notice here, we just had to have what number we were on. If I wanted to find the 50th term, I would just plug in 50. Right? If I wanted to find the 600th term, I would plug in 600. But here, you have to plug in the one that's right before it. So you have to have the term that was directly before it in order to do anything. You can't just find the 100th term without the 99. So recursive formula is a little bit harder. So let's go ahead and get the second term. So our second term is 2 times a. 2 minus 1 gets me 1, a sub 1. Oops, that's a plus. There's my eraser. Try that again. Plus 5. So you have to know what the first term was, which luckily we do. We know the first term was 3. So 2 times 3 is 6, plus 5 gets me 11. So we've got first term, second term. Let's find the third term. Again, it's 2 times a. 3 minus 1 is 2, a sub 2 plus 5. That means you need the second term to find the third. Luckily, we have the second term. It was 11. So recursive formula is a little bit less user-friendly. 2 times 11 plus 5 gets me 27. And then our fourth term, again, to get the fourth, you need the third. What do we got? 2, 4 minus 1 is 3. So 2 times my third term, which was 27, plus 5. And we get 59. So recursive formula, like I said, it's a little bit harder to find the terms because you have to have what was directly before it. All right, moving on. We're also going to see some factorials. Okay, we're going to see some factorials. Understand what a factorial represents. If you had 4 factorial, that means it's 4 times 3 times 2 times 1. So 4 factorial is 12 times 2 is 24. All right, so notice you just keep subtracting 1 all the way down to 1. 4, 3, 2, 1. So this says write the first 4 terms. Let's try it. We'll start over here. Our first term is 20 over 1 plus 1 factorial. So we have 20 over 2 factorial, which is just 2 times 1. So 20 over 2 times 1 is 2. So you get 10. All right, our second term is 20. Oops. No, go back. 20 over 2 plus 1 factorial. So we have 20 over 3 factorial. 3 factorial is 3 times 2 times 1. So 3 times 2 times 1 is 6. And here we're just going to simplify this. These are both divisible by 2. Both divisible by 2. So we're going to get 10 over 3. We're just going to leave it there. Our third term, 20 over 3 plus 1 factorial. So it's 20 over 4 factorial. And again, remember 4 factorial is 4 times 3 times 2 times 1. And we actually have it right here. So 24. These are both divisible by 4. So we get 5 over 6. And last but not least, 20 over 4 plus 1 factorial. So we have 20 over 5 factorial. And again, 5 factorial is 5 times 4 times 3 times 2 times 1, which gets you 120. These are both divisible by 20. We get 1 over 6. All right, so that's working a little bit with factorials. A little bit more. So you do not want to write all of this in a calc. You don't want to say 14 times 13 times 12 times 11. That would get a little excessive. So you can actually start it off. Let's start it off writing 14 times 13 times, we're just going to write 12 factorial because we don't want to keep going. We're lazy. All right, 14 times 13 times 12, 11, 10, 9, 8, 7, 6, all the other stuff. And the reason we stopped there is because look at the denominator. See that 12 factorial? Those will actually cancel for us. So we can cancel those out. This looks a lot easier, right? Now we only have to do, you simplified, right? You simplified something that did not look very fun. So what do we got? 14 times 13 is 182. And now 2 factorial is just 2 times 1 is just 2. So you got 182 divided by 2 is 91. So that's seeing it with numbers. You can also do it with variables. Remember, n factorial is n, and then you're going to subtract 1 every time, times n minus 1, and I'm actually going to stop there. Times n minus 2, times n minus 3. All right, the reason I want to stop there is because look at that denominator. So those n minus 1 factorials will cancel out. Much nicer. We like n. Much nicer than it looked originally. All right. So summation notation, that's what you have this little epsilon, is the summation. So this is the summation from 1 to 6, and they give you the function to plug into. So that means you're going to plug in I is 1 all the way up to 6. So 2, 3, 4, 5, 6. And summation means we're going to add them all up, and that's what this is talking about here. You're going to add them all up, all the way up to 6. So we're going to have 2 times 1 squared plus. We're going to have 2 times 2 squared plus. We're just going to keep plugging in. 1, 2, 3, 4, 5, I'm running out of room, 6. So all we did was we plugged in 1, 2, 3, 4, all the way up to 6. And summation means we're going to add them all up. So here we have 2. We have 2 squared is 4 times 2 is 8. We have 9 times 2 is 18. 16 times 2 is 32. 25 times 2 is 50. And 36 times 2 is 72. Add them all up, you should get 182. So this summation is 182. Let me put a little squiggly here so we know where we're at. Here, same concept, except we're starting at 3 all the way up to 5. So 3, 4, 5. We're going to plug them in. 3, all right, plus 4, plus, and we're going to plug in 5 as the last one. So you're just plugging in those k values. And then you evaluate. 2 cubed minus 3, so 8 minus 3 is 5. We got 16 minus 3 is 13. And 2 to the 5th minus 3 gets us 29. Add them all up, 47, and we're done. Now this one looks a little weird, right? Where do I plug it in? This is telling you the first term is 4. The second term is 4. Third term is 4. Fourth term is 4. Fifth term is 4. So I did 1 to 5. And add all those up, you should get 20. So it's actually nice when there's no I in there. All right. Last but not least, this one we actually want to put it in summation notation. So we're going to say summation. We'll use the letter I. So we want I. All right, let's see what we got here. 1 squared, 2 squared, 3 squared, all the way up to 9 squared. So we want I to be squared. And we want I to be from 1 all the way up to 9. So we're going to plug in 1 squared, 2 squared, all the way up to 9 squared. That was pretty, you see that pattern right away. Here, you don't necessarily see the pattern right away. But if you look towards the end, if you look towards the end, this will kind of tell you the pattern you're looking at. So we're here. We're going to use I again. So we're going to say 1 over 2 to the I minus 1. And then what do we want I to be? Well, we want I to start at 1. Because think about it, 1 minus 1 is 0. Anything to the 0 power is 1. 1 over 1 is 1. That'll get me my first term. And then we want to go all the way to n. Right? We want to plug in n. 2 to the n minus 1. 1 over 2 to the n minus 1. So this one kind of gave you the hint in the right direction if you look at the end. All right, that's it, guys. Get your homework done.